5 space facts that make no sense. What if I told you that 95% of the universe is completely invisible, that gravity might not work the way you think, and that empty space isn't actually empty? Welcome to the final frontier of unexplained phenomena, space. It's vast, it's mysterious, and frankly, it's full of things that should keep you awake at night wondering how any of this makes sense. We live in a universe where the more we discover, the more we realize we don't know. And today, I'm going to share with you 5 space facts that will make you question everything you thought you knew about reality itself. Let's start with something that should blow your mind. Everything you can see, every star, every planet, every galaxy stretching across the cosmic web represents less than 5% of what's actually out there. The rest, it's invisible. We call it dark matter and dark energy, and together, they make up 95% of everything that exists. Dark matter doesn't emit light, doesn't absorb light, doesn't interact with light at all. Yet we know it's there because we can see its gravitational effects on visible matter. Galaxies spin too fast, galaxy clusters move in ways that shouldn't be possible with just the matter we can see. It's like watching a cosmic puppet show where we can see the puppets dancing, but the strings and the puppeteer are completely invisible. And dark energy? Even stranger. It's the force that's accelerating the expansion of the universe itself, pushing galaxies apart at an ever-increasing rate. But here's the kicker. If we can't see it, touch it, or directly detect it, how can we be so sure it exists? Now let's talk about gravity. You think you understand it, right? Things fall down. What goes up must come down. Simple. But Einstein showed us that gravity isn't a force at all. It's the curvature of space-time itself. Massive objects literally bend the fabric of reality around them. But here's what doesn't make sense. Gravity is by far the weakest of the 4 fundamental forces. A small magnet can overcome the gravitational pull of the entire Earth when it picks up a paperclip. Why is gravity so pathetically weak compared to electromagnetic, strong nuclear, and weak nuclear forces? And then there are gravitational waves, ripples in space-time itself, traveling at the speed of light. When 2 black holes collide billions of light years away, they create waves that stretch and compress space so minutely that we need instruments more sensitive than anything ever built to detect them. We're literally listening to the universe ring like a bell from cosmic catastrophes that happened before Earth even existed. Gravitational lensing shows us that massive objects can bend light itself, turning galaxies into cosmic magnifying glasses. Light doesn't have mass, so how can gravity affect it? Because gravity doesn't pull on mass. It curves the very space that light travels through. Speaking of things that make no sense, let's dive into black holes. These aren't actually holes at all. They're regions of space-time where gravity has become so intense that nothing, not even light, can escape once it crosses the event horizon. At the center of every black hole lies a singularity, a point where our understanding of physics completely breaks down. Here, density becomes infinite, space-time curvature becomes infinite, and the laws of physics as we know them simply stop working. It's not that we don't have good enough theories, it's that the very concept of physical laws becomes meaningless. Black holes warp space-time so severely that time itself slows down near them. Fall toward a black hole, and from your perspective, you'd experience time normally, but to someone watching from a safe distance, you'd appear to slow down and freeze at the event horizon, your image gradually fading and redshifting until it disappears. And here's the really mind-bending part. According to some theories, black holes might not destroy information at all. Instead, everything that falls in might be encoded on the surface of the event horizon. Like a cosmic hologram, are black holes truly the cosmic vacuum cleaners we think they are? Or are they something far more complex and strange? Now let's shrink down to the smallest scales imaginable and talk about quantum space. You know that empty space between atoms? It's not empty. At the quantum level, space itself is alive with activity, a seething foam of virtual particles constantly popping into existence and annihilating each other in time frames so brief they barely qualify as existing at all. This quantum foam means that space itself is constantly fluctuating, appearing and disappearing, stretching and contracting at scales trillions of times smaller than an atom. The vacuum of space isn't a void. It's a dynamic, ever-changing quantum battlefield where the very fabric of reality is in constant flux. Some theories suggest that these quantum fluctuations might be responsible for the Big Bang itself. Imagine that. The entire universe, with its hundreds of billions of galaxies, might have started as a quantum fluctuation that got out of hand. We might be living inside what amounts to a cosmic accident. Finally, let's address perhaps the most profound question of all. Are we alone? Recent discoveries have revealed thousands of exoplanets, many in the habitable zones of their stars. We've found worlds with liquid water, organic molecules, and conditions that could support life as we know it. But here's the paradox that keeps scientists awake at night. If the universe is so vast, so old, and filled with potentially habitable worlds, where is everybody? This is the Fermi paradox, the contradiction between the high probability of extraterrestrial life and our complete lack of evidence for it. Maybe life is incredibly rare. Maybe intelligence is even rarer. Maybe advanced civilizations inevitably destroy themselves. Or maybe they're out there, but so advanced that we're like ants trying to understand the internet. We simply lack the capacity to recognize their presence. The universe is 13.8 billion years old and contains more stars than grains of sand on all the beaches of Earth. If we're truly alone, that might be the most mind-boggling fact of all. But if we're not alone, if there are others out there looking up at their night sky and wondering the same things we are, then we're part of something far grander than we can imagine. So the next time you look up at the stars, remember, you're not just looking at distant suns. You're peering into a universe that's 95% invisible, governed by forces we barely understand, filled with objects that break the laws of physics, built from quantum foam, and possibly teeming with life we haven't yet learned how to find. And somehow, against all odds, you're here to witness it all.